So, this we are discussing about the reciprocal lattice. So, it has relation with the space lattice, crystal lattice, and we have defined the axis system B1, B2, B3, B1, B2, B3 in connection with the A1, A2, A3. So, also we have seen the important relation, it is AM dot BM BN equal to 0 or 1 when M is not equal to N and when M equal to N, right. And reciprocal vectors equivalent to the translational vector in space lattice. So, reciprocal vector H, I wrote H B1 plus K B2 plus L B3, right. So, this, as I told that just I have written taking Miller indices. So, this what is the what it represent? What it represent? So, it basically we will see that this H is its magnitude will be just 1 by DHKL. So, now if H is related like this, if H follows this relation, so now we can say that this HKL whatever I have taken that is justified, right. So, H written in this form, so then H, magnitude of H will be the reciprocal of the planar spacing of HKL planes, right. So, this planar spacing is DHKL. Okay. So, that we have to prove, okay. And then another it represents that from A1 B1 B2 A1 sorry B1 B2 B3 this axis system, it has origin. So, this vector will represent if this is the origin for B1 B2 B3 B1 B2 B3 and this is a translational vector, like we are telling reciprocal vector H, right. If its coordinate this HKL, right. So, this which point? So, in this axis system these are the HKL point, right, HKL point coordinate, like in XYZ coordinate system we represent a point with XYZ coordinate. Similarly, here B1, B2, B3 in this axis system if this is a vector, so this end of this vector will be the point HKL, right, and this will be direction of this one, it is basically perpendicular to the HKL plane. So, H magnitude is this and its direction will be perpendicular to the HKL plane. It has to be perpendicular to HKL plane, because that is why that is what we have seen in Laue spot, right. So, Laue spot, each spot is basically one plane. We are identifying that or designated each point with the HKL value, right. So, if you imagine that this Laue spot, if they are the reciprocal lattice, they are in reciprocal lattice. So, if I go from one point to the another point, okay, so each point are representing the lattice, this lattice plane. So, this if I just draw taking origin just one point, if I draw a straight line up to the another point, so that will be the direction of this plane, right, and it will be it is basically perpendicular to that plane. Okay. So, that is what this Laue spot we try to explain, right. So, from each plane, each set of planes we are getting one Laue spot. Where we will get Laue spot? So, so that depends on the orientation of the lattice planes in this crystal system. So, depending on that orientation, we will get the distribution of the Laue spot, and that each spot corresponds to a plane. And now we are seeing that the distance, if I take a origin and if I just draw a line to up to any point, so it will represent the normal to the corresponding to that plane, and this magnitude of this line will be the reciprocal of that planar spacing. Okay. So, that is the necessity of this reciprocal lattice. So, in a plane or in a space where we are getting the diffraction pattern, so that space is basically, if I define that space with some other coordinate system, axis system, where I can identify or I can represent each point with just with coordinate. So, task will be easier than the explaining the result in terms of the lattice plane. So, in terms of lattice plane, as I mentioned that orientation etc. So, it is slightly difficult, but it will be easier if I can represent, if I can explain the things just using the coordinate as like translation vector, as I mentioned UA1 U plus V A2 plus W A3. So, here just these are giving the points and the coordinate of those points U V W in space lattice. Now, we will tell this lattice, space lattice, is a direct lattice. Okay. So, because other one we have defined another lattice, so that is called reciprocal lattice. So, just to differentiate these two, so this space lattice will called the direct lattice. So, in direct lattice whatever the points we can designate those points using the just coordinate u v w, okay. But planes we cannot define in simple way. To define the planes we have to find out the Miller indices and then we can define. So, in terms of Miller index we have to define, and so we have produced another type of lattice that is called reciprocal lattice, where this each point will represent the planes. So, now in this lattice here we will be able to represent the planes just using the coordinate. That coordinate, as I told, is that will be h scale. Okay. So, that is the advantage we will get using the reciprocal lattice to study the direct lattice. So, our aim is to study direct lattice, but this is the alternative, this is the convenient way to deal with the crystal structure. So, I think it is clear what is reciprocal lattice and how it is defined, what are the axes of this lattice and how these axes are related with the direct lattice, because it cannot be arbitrary, right. So, our aim is to explain the direct lattice crystal structure. So, we are forming alternate reciprocal lattice to analyze the diffraction pattern, X-ray diffraction result, from where we will extract the parameters for real crystal. Okay. So, now as I told this I have to show that H is basically perpendicular to H scale plane and its magnitude is just inverse of the planar spacing of H scale planes. Okay. So, to show that one I have to I will let us take a axis system in direct lattice A1, A2 and A3, right. So, using this axis system, if I just draw a plane, I think I should draw properly, otherwise it will be, I think this way if I draw, yeah. So, I think this is a plane ABC, okay. So, it will intersect A1 axis by A1 by H, right, that we have seen earlier. So, B1 it will I think it will be, this intercept will be A2 by A, right, and this intercept will be A3 by A, right. So, So, this magnitude will be A1 by H, this magnitude will be A2 by K, and this magnitude will be A3 by L, right. So, this is then this is a H scale plane, okay. If it is a H scale plane, so this is a H scale plane, right. So, H scale plane, it intersect at A1, A2, A3 axis by this, okay. So, this is the origin. Now, let us take a normal on this plane. Let us take a normal on this plane. So, I will use say different color. So, this is the normal on this plane. This is the normal on this plane. So, this is the say n, ON is the normal on this plane, ON is the normal on this plane, okay. So, this is the this normal on this plane, if it is ON, so so if ON is normal on this ABC plane, and this if this normal, so normal on a plane, if I represent with this one, if I represent H equal to HB1 plus KB2 and LB3. If I take the direction normal on this plane, if I take this one, because whether this now I am going to prove whether it is normal on this plane or not, that I want to verify, right. So, this is a normal on this plane. So, I am taking this is vector H, this, okay. So, if it is normal on this plane, so it will be, and AB, BC, CA, they are on this plane. So, it will be so this H has to be normal on this AB also, or BC also, or CA also, right. So, if so, then if I can show that H is normal on, is perpendicular to AB, right. If I show that H is perpendicular to AB, then it is, I can tell that H, or other way one has to show on other line also one can show that this is perpendicular. So, then yeah, so then it is confirmed that this H is perpendicular to this plane. So, here AB, so if I take vector OA, and this is AB. So, from here I can write OA plus AB right, OA plus AB equal to OB, equal to OB, equal to OB, right. So, AB equal to OB minus OA, right. Now, what is OB? What is OB? OB is basically A2 by K. OB is basically A2 by K, right. And what is OA? OA A1 by H. So, minus A1 by H, right. So, if in this direction unit vector is n, is along this normal direction, if it is unit vector is n, right. So, n dot, so n dot AB, n dot AB will be n dot AB. What it will give me? N dot AB has to be the perpendicular, if they are perpendicular, cos theta 90 degree, cos theta 90 degree. So, it will be, it has to be 0. If it is 0, then this direction is basically perpendicular to this on AB, at least before telling this on this plane. So, n is h by magnitude of h. So, that is the unit direction, right. Dot AB, AB is this, and h, if h is this, we have taken, right. So, this h I can write HB1 plus KB2 plus LB3, right, this, and then dot product of AB, then dot product of AB. What is AB? A2 by H minus A1 by K, sorry, it is K and it is H, right, and that magnitude of this one is there, okay. Now, this equal to, here just see this relation. So, B1 dot A2 0, m is not equal to n, B1 dot A1 it will be 1, right. So, I will get minus H, B1 dot A1 is 1. So, H 1 by H, right here. Then B2 A2 1, B2 dot A2 1. So, I will get plus K dot, it is 1 by K, right, and there is B3 A2 0, B3 dot A1 the 0, right. So, here you are getting minus 1 plus 1 equal to 0, okay. So, H is normal to AB. When, if I take H equal to HB1 plus KB2 plus LB3, then only it is 0, otherwise not. Okay. So this way I justified. So I proved that this reciprocal vector, it will be in terms of its coordinate will be in terms of HKL. Okay. So similarly you can show this it is H is perpendicular to AB, H is perpendicular to AB, H is perpendicular to BC, you can show, or H is perpendicular to AC, that same way you can show. So that means H. So if this is normal to two vectors on this plane, so one can tell that is the normal to that plane which contain these two vectors. Okay. So similarly one can show this other one or two, and then I can say that H in this form, this is very important. This just I wrote, after writing I am just proving. H in this form, it is normal to the HKL plane. Okay. So that I have proved. Now I will show that the magnitude of this H is nothing but 1 by dHKL. It is nothing but dHKL. Okay. So they just easily one can show that this I have to show this what is the magnitude of this ON, right. This is the normal of this plane, and what is the magnitude of this ON, and that is nothing but the magnitude of that is nothing but the this is the magnitude of the or this planar spacing of this plane, right, HKL plane. So basically I can write, I don't need this one, so I can so what I need that I want to get the value of ON, and this is known to me that this is dHKL, right. This is dHKL because as earlier I have mentioned in earlier class. So this plane from origin, at origin we can consider, always we consider this parallel plane of this one. So if you draw a normal from origin to this plane, so that is nothing but the planar spacing. Okay. So this ON is nothing but the dHKL, right. So this ON one can get this taking the projection of this OA on this, right. So projection, so if this is the unit vector, so just take dot product of OA, okay, dot product of OA in this direction if you take, so that will be this ON, right. So you can so you can here replace this again, this N is nothing but this one, N is nothing but this H by H magnitude, right, H by H magnitude, and then OA is that A1 by H, right. So as if here I have whatever this term I got, anyway, so I will do it. So, from there itself I could tell anyway. So, this what it is giving me. So, this H vector is basically this one H B1 plus K B2 plus L B3 dot A1. So, you know, following this one only m equal to n will give 1, otherwise 0. So, A1 dot A1 means it will this term will exist, other will be 0. So, I will get basically here H B1 dot A1, that is A1, that is 1, and by H is there here, right, and I have this. So, okay, let me write this this into 1 by H. So, from there 1 by H. So, B1 dot A1 is 1 and other term will give 0. So, this basically you are getting 1 by magnitude of H. So, DHKL is equal to 1 by magnitude of H, right. So, H magnitude of H is nothing but 1 by DHKL. Okay. So, here what is representing? Reciprocal vector. This is reciprocal vector, and we have to write in this form where this coordinate is x y z value is HKL, right. XYZ mean XYZ coordinate system we designate a point by XYZ. Similarly, in reciprocal lattice, so this in B1, B2, B3 this in that axis system, so point will be represented by HKL. Okay. So, and this vector is perpendicular to the plane HKL. Magnitude of this vector is inverse reciprocal of the planar spacing, HKL planar spacing. And if I draw this vector from the origin, so end of this vector, this coordinate of the end of the vector will be HKL. So, all this information contained by this. So, I will stop here. Thank you for your kind attention.